Hey everyone, welcome to the channel. My name is Nader. In this video, we're going to go over regular expressions together in JavaScript specifically. Now, regular expressions actually apply to every single language. In fact, I guess technically most of the stuff we've been learning in JavaScript together applies to a lot of other languages, but regular expressions specifically are kind of a language outside of JavaScript that we can use inside JavaScript to accomplish certain tasks. This is quite a deep topic, so this is mainly going to be kind of a cursory intro for the most common use cases of regular expressions, and then in future videos and also for yourself, I'll show you where you can actually find more documentation to actually take a look to go deeper if you so wish. This is also one of those things where you're probably going to be Googling it anyways when you actually do need to reach out for it, but actually knowing kind of the use cases and what it's used for is extremely valuable when the need actually arises. So that said, let's get right into the video. Okay, so regular expressions. I want to kind of just set up this video by explaining kind of why we even need this concept to begin with. So I have a couple of strings here. Imagine that these are strings in JavaScript. Okay, so here we have monkey@trees.com, 1337 banana crossing, looks like a phone number of some kind, and then maybe some company name. Okay, now imagine that these are all strings. Now the interesting thing is that if you think about some things like emails or addresses or maybe phone numbers specifically, or even sometimes maybe company names, there's always some kind of pattern to these, right? Like for example, maybe an email has to have an @ symbol, or maybe it has to have a dot something or .com, right? It's not always .com, but maybe it's a series of kind of a limited set of dot somethings, right? Now, if you think about the question, how would we check to see if a string is an email, right? Currently, with our knowledge, we don't really have great options, right? Maybe we can check to see if it includes a @ symbol. We can probably see if it includes a com or a .com, right? We could even probably go further and say, does it end with .com, right? But really, we can't kind of make a more robust system where we can kind of look at like what's the part before the @ what's the part after the @ maybe there's multiple dot somethings, right? And those are all still valid. We don't want to kind of deny those. Same thing goes for things like phone numbers. I'm sure you've seen many different formats for phone numbers. Some have the kind of country code, some don't, some have an area code. So it's kind of complicated to actually try to think of like how you just use, for example, like a string includes or contains or something like that to figure out like a nice single pattern for this. So that really is the rationale for this concept of regular expressions, and that's also why it's used in pretty much every language, because every language needs a way to test strings to see if they match some pattern. Okay, so that said, let's take a look at specifically in JavaScript, how do we create regular expressions? So here we go. We have two main ways to create regular expressions in JavaScript. This first one right here, and we can use this new RegExp constructor to actually give it kind of a pattern, and we'll see these patterns in a second. Or kind of another syntax is using what's called the literal method, which uses these backslashes to kind of put the thing that we're searching for, or the pattern that we're searching for, in between. Now, both of these are totally valid. They both do the exact same thing. I'm just going to use this method because it's way less typing, and a lot of programmers don't like to write more. They would want to write less. And frankly, I think that this, once you start getting more complicated expressions, is just a little bit easier to read. And there's some nice syntax highlighting that we get depending on the editor and plugins that you're using. So you can definitely use both and you'll see both, but I'm going to use this one going forward. All right. So let's get right into how this actually works. So let's set up the scene here. Let's say that we have a sentence, okay? So right here we have a string, and I'm assigning the variable sentence to that string. And the string is, there once was a monkey who knew JavaScript ... right? Just a regular string, nothing fancy about it. What we can do is we can create a pattern using a regular expression. So in this case, I'm using that literal syntax with the slashes, and I'm asking to look for the pattern monkey, monkey, right? And it has to be exactly in that order somewhere in this string. Now we can do this currently with our string methods, but we're going to build on this, so we'll start kind of simple and then build up from it. Now we can kind of do two things. we can test to see if it even exists in the first place and get a regular Boolean value. So true or false, does this pattern match at all in general, or does it not match? Is it not there at all, right? So we can do a test on the actual regular expression object. So we can do pattern.test. So pattern is a regular expression. We can do .test on it and then give it the string that we're testing. So in this case, this sentence is asking, does this pattern show up anywhere in this sentence? That's kind of how you would read that. Okay, yes or no, true or false. We can also use it kind of in another way where we actually take the sentence and we match on the sentence using the pattern. So this kind of, if you were to try to read this out, you would say, does this sentence have a match for the pattern that we're going to give it, right? So in this case, does this sentence up here, there once was a monkey who knew JavaScript, have a match for kind of the monkey all in a row, right? M-O-N-K-E-Y. And this is not going to return true or false. This is going to return the actual match. Okay, so we get back something that looks like this, which is an array. And we get different results depending if there's multiple matches or not, if we use certain syntax, which we'll see later. But for now, we're only searching for kind of the first match. And we're going to get back the match, which is monkey. So we found it. We're going to get the index that it starts at, which is index 17 inside of the string. If you were to think of the string as an array of characters, it would be index number 17, where we start seeing this match. Then we get the actual input, which is kind of nice, which is the entire string. And then we have this groups thing, which is a bit more advanced, which we're not going to get into, but you can look up or we'll look into in future videos as well. So that's pretty cool, right? We get a lot of nice information here for the match. Now, arguably, we could technically get things like the index and whether it's a match or not using the string methods currently. But as we'll see shortly, we can really build on this to do really fancy things. Now, let's actually look at this in code before we go any further with this, before we get too overwhelmed with all the possibilities. So I'm just going to pull up VS Code. I'm just going to create a new file. I'll call this intro.js. And I'll just go with this string. There once was a monkey who knew JavaScript. So I'll say const sentence equals there once was a monkey who knew JavaScript, right? Perfect. Then we can create a pattern. And as I mentioned, there's two ways to kind of create this with the regular expression object, or we can actually just use the literal syntax. And I'm going to use the literal syntax. So I'll just say pattern, and the literal syntax looks like this. We have two backslashes, which is the kind of question mark without the shift. And then we have our semicolon after. In between these backslashes, we put the search term, right? So for example, if I search for was, I'm saying this is a regular expression that's searching for WAS all in a row. Okay, so we can do two things with this. We can test and we can match. So for example, if I say const test is equal to, and I'll take the pattern. So I always get these confused, and you're probably going to Google this anyways as you look it up because they're kind of reversed. But if you take the pattern and then you do a .test on it, you can give it a string to search through for that pattern. And in this case, we're searching through sentence. So if I do a console.log of our test variable, we're going to get back either true or false. So let me log this out really quick. Make sure I'm in the right folder. I'm going to run node intro.js, and we do get true. Right? So if I search for something else like waza, right, W-A-S-A, and I try to run this again, you'll see that we get false because that doesn't exist inside of the string. Okay, hopefully that makes sense. Perfect. So I'll change that back to was. And now what I'll do is I'll check for a match. So I'll say const match, and this is kind of the reverse. We take the string and then we match on it using the pattern. So our string is sentence, and all strings have a method on them called match, so .match, and we can pass it a regular expression object, in this case pattern, that it will match on for that specific string. So in this case, if I do a console.log out of our match, oops, let me just clear my console here so I don't go over my head, and there we go. So you can see that we have a true being logged out from test, and then we have our match being logged out right here, which is pretty awesome. We can see that was shows up at index 11, so you can verify that by counting 0, 1, 2, 3 all the way to 11. So it starts at 11, and then our original input string, as well as groups that I said that we're not going to go through right now. Perfect. So that's pretty awesome. So if I change this to, for example, again, just was a, and I try to run this, you'll see that we get back null, which means that it wasn't found as a match inside of the string. And we also get back false, which is fantastic for our test, which makes perfect sense. Okay, great. Cool. So let's keep going with this. So let's jazz it up a little and really see the power of these regular expressions. So here is a table of some important patterns and tokens, which are kind of these things in these brackets and some other specific keywords within regular expressions that we can use to do more advanced matching. So we've seen this one right here, right? That's what we just did with was, right? We just put was inside of it and it's going to match WAS or anything that we put in there in order, yes or no, or it's going to return a match, right? But we can actually be a bit more advanced. We can do stuff like this, right? So let's look at these one at a time. If we put some square brackets and then put a bunch of characters inside of there, we can match on any of those in a single spot. Okay, so what does that mean? For example, let's just say that instead of was, I want to match on A, B, and C. Okay, if I run this, what we'll see is that we actually do get the same results because we're asking, look for a W followed by any A, B, or C character followed by an S. Right? So if I change was in the sentence to a B, WBS, a monkey, right, we will get the same match. But if I change it to, for example, a Z, and I try to match this here, or a Z, depending on how you like to pronounce that, you'll see that this is no longer a match, right? Because Z or Z is not inside of these brackets. So this is going to match a single character the way that it's set up right now, in that spot. So W and then either A, B, or C, and then an S. So I'll change that back, and then we'll see that we get our match. Perfect. Cool. Then a single character not A, B, or C. And that is if we prefix kind of that the start of those square brackets with a hat character, actually for a caret character, I think it's called, at the very start. So for example, if I did anything that's not an A, B, or C, that's how you'd read that. So a W followed by anything not A, B, or C. So D, E, F, G all the way to Z, right? So if I try to run this now, we won't get a match. But if I change this to, for example, a Z again, we will get a match because now this is not A, B, or C right here, this Z character. Perfect. Finally, we can give ranges because you can imagine if we wanted to match like everything between A and G, for example, we could technically do that. We could say A, B, C, D, and then we can keep going all the way to G, right? But that'd be really, really annoying. So we could technically just do this, A to G, for example, right? And that would say any character in between A and G, right? So for example, if I put a D in here, right, we'll see that this will match. But if I try to put my Z back in here, it will not match because Z is not between A and G in the alphabet. Okay, perfect. I just want to show you as well that the way that we have this set up right now, if I try to put a capital A in here, this will not match because the way that we have this right now, it is case sensitive. Okay. So we can see how we can make it not case sensitive, but also if we wanted to make this case sensitive for now, we could say A to G, for example, and then this would match with a capital A to G. We can actually combine these, which we'll see later on as well. Perfect. Okay, so that kind of covers it. This is an example, right, that I just showed. If we take kind of another word inside of the string, if we were to take, there once was a monkey who knew JavaScript, but we changed the O to a U, so we have this kind of monkey. We could use a pattern like this, right? So match an M followed by an O or a U, in this case, NKEY, and then we would get true and we would get that index. Right? So very, very similar to what we just saw with our searching for was. Perfect. Now, let's build on this a little bit more. I promise I'm not going to get too crazy because you can really, really go down the rabbit hole with this stuff. And I just want to stick with kind of the main overarching principles. And then as you need it, you'll always find ways to actually test this. And I'm going to share a resource as well in a second. But let's look at a couple more patterns. So we can give a period, right, or a dot character, and that will match any character. Okay. If we give a question mark after a character, we can match a 0 or 1 of a single character. If we give a star, it'll be 0 or more of a single character. A plus is 1 or more of a single character. And then we can match kind of very similar to how we did kind of like A to Z. We can match any word character using the backslash lowercase w, or any non-word character using the backslash capital W. And same for digits, we can match any digit, for example, 0 through 9 with a backslash D, any non-digit with a backslash capital D. So you can kind of think these as shortcuts for the bracket notation that we use, for example, lowercase a to Z, and a couple other characters in there for the words. And then digits would just be like a brackets and then 0 to 9, for example. All right, so to show you an example of this, to really kind of nail it home here, let's look at this example, and I'll switch back to code so we can actually test it with our actual example using a different word as well. But imagine we have this sentence, right? So imagine that, for example, we spelled monkey or something, right? Or we had this funny word in here, muni, right? If we had this pattern, now this looks kind of crazy, so we'll go through this really carefully in a second, but we can use this pattern to do the same thing, test, match, and then we will get that muni matched at index 17. So what this pattern is saying, one step at a time, is find something that starts with M, then any letter, then an N, then a 0 or more case. So in this case, we are doing this one right here, 0 or more, right? So 0 or more case, then an E and a Y. Okay, so that is a little bit confusing, but if you really kind of read that out, what that's saying is, okay, we have an M, then we have another word character, which is a U, so that matches. Now we go to the N, then we're looking for 0 or more case. Well, there's 0 case, so that's fine. We match. We don't have any case, so we can ignore that. Then we look for an E and then a Y. Okay, so then we get this match. Hopefully that makes sense. So let's kind of have this table here and look at a couple of examples. So if I take this exact example and I just change this to a backslash W, so the backslash is the one above the enter key, is different than the forward slash, which is used to start the regular expression. And then we run this, we'll see that this is true because this is effectively the same thing almost as the A to Z. Technically, what this is actually doing is it's a shortcut for, among other things, A to Z and then A to Z like this. I believe it includes other characters as well, but we're not going to go there because this is simple enough for what we need right now. Okay, so we can actually say the same thing, similarly same thing, using either A to Z lowercase or A to Z uppercase like this, but instead of typing all that out plus a few other characters, I believe, we can just do backslash W. Now, if we say backslash capital W, that's saying any non-word character, right? So that means we can't have a word character here. So for example, if I put a 1 here, in this case, this is still false because the way that this rule is set up is that even a 1 counts as like a word character actually. So that's actually a good example of how if I was to match with this, we would still get true, okay? Now this is definitely kind of confusing, and sometimes you have to be really careful when you kind of use these more broad ones. You have to really look up what the backslash W is actually doing and what it actually expands to inside of things like this. But for example, if we do backslash D, which is a digit character, we still get true. But if we say backslash capital D, which is not a digit character, we get false. So that kind of makes sense. Okay, so backslash W can be pretty broad, so definitely be careful using it. I just want to show you that if you do see these kind of backslash things being used in there, that is kind of the purpose of them. Okay, you just have to be careful to look them up. So if we were to do a dot, for example, I can actually remove this and I can just say dot and then dot, and this would match a W and then any character, and then an S. So if I run this right now, we won't get any matches because we have a W and then we have any character, but then we don't have another character before the S. So if I was to add a 2 here, for example, now I would get a match because now I have 2 things in between the W and the S. In this case, even though they're both numbers, it still works correctly. Okay, perfect. Now, I'm definitely skimming the surface here. So you probably were like, oh my gosh, but what about this scenario? What about this scenario? What about this scenario? The best way to do this is really just to test it out. And you're always going to come up against a case where you're going to have some custom expression, and it's going to be quite unique to your scenario that you're testing for. And you're just going to have to kind of figure it out and play with these different operators to figure out what the best expression to use is. Generally speaking, you want to be more specific with your expression at the risk of, the risk would be you match on things that are not supposed to be within your matching set. So you want to be more limited, generally speaking, when you use regular expressions. So to kind of show you what I mean with that, let me just pull up Google real quick. So here we go. We have Google. Not really sure what this one is. It looks kind of cute. Let's just look up JavaScript RegExp. That's short for regular expressions. And you can see this resource, which is the documentation for regular expressions. I'll give you a chance to read that kind of on your own. We won't go through it here because it gets quite intense. But if you scroll down a little bit, actually, if you just search for regular expressions, so JavaScript regex will get you the documentation specifically for JavaScript. If you just search for regex by itself, you'll get a different set of resources, I guess, including the JavaScript one. I like to use a couple specifically. If you scroll down a bit, eventually you might find this one, regex 101. So if I open that and I zoom in a little bit, what you'll see is a pretty neat kind of editor. We can choose kind of the flavor of our regex. So most of the time we're going to be using JavaScript in this course at least. And you can kind of put your expression here. So for example, if I search for monkey and then I do like there was a monkey in the tree, you can see it kind of highlights the thing and the position that it actually finds it in. And you can see all the different operators down here, all these crazy amount of tokens, which we don't have time to go through in this video. Hence why I want to keep it quite simple. So every time I actually need to use regex, I actually pretty much pull up a site like this or a tool like this and test it out just to make sure that it's actually working correctly and kind of other edge case scenarios where it might catch or not catch certain things. Perfect. Now, let's head back to our slides. So the last couple things I want to show is just kind of this concept of anchors. So anchors and flags specifically, I should mention. Anchors are these things right here. We can ask the search to search starting at the start of a string, for example, or marking the end of a string. Okay, so this is useful for things like, for example, maybe an address or maybe specifically an email or other things, right? We can ask, does it start with this thing or does it end with this thing? Okay, so we would put this at the very start of the regular expression or the very end of the regular expression. There's these things that we can kind of add as modifiers as well called flags to the actual regular expression object itself. So when we actually create the regular expression, so for example over here, if you look at how we're creating this, we can at the end of the regular expression add these kind of modifiers, right? Or flags as they're called. There's a bunch of these. The two most commonly used ones are the I and the G. And I is a case insensitive match, which means that all of the casing, so capital and lower casing, everything is pretty much just lowercase. Okay, so, or I guess uppercase. It ignores the case, right? The casing doesn't actually matter. So if we did that capital A or lowercase a, it will still match if we just search for A. The G is going to return all of the results. So right now when we use match, we only stop at the first found result. If we use G, what we'll get back is actually an array of all of the matches inside the entire string. Okay, we can also combine these like this, for example, GI, and we can combine I and G. So this would be a case insensitive global match. All right, so just to show you an example of this, and we'll code this in a second. Here is our sentence. There once was a monkey who knew JavaScript. What we're doing with our pattern here is we're looking for the word there. Right? T-H-E-R-E. But we have this caret at the start, right? The little arrow that points up at the very start. That's saying that the string has to start with this phrase in order to match correctly. We also added some flags here, which is case insensitive search and the global modifier. So if there's more than one match, we're going to return all of them. And case insensitive means that in this case, capital T and lowercase t are going to be the same match. Okay, so in this case, if we test it, we do get true because it does start with there, right? Even though it's capital because of the case insensitivity. If we use match, now since we have the global modifier, we actually don't get back that nice fancy object. We actually get just back an array of all the string matches. Okay, so let's take a look at this really quick. So if I wanted to, for example, check to see the start of this string, I would do a caret, and then I can do there. So if I do this right now, what we'll see is we get false, right? Because it does start with there, but it is an uppercase T. So be aware that uppercase T and lowercase t are totally different things. Now, technically what we could do is we could say a T or a T, right? And if we run this, then we'll get back true. Another way to do this, though, if we didn't really care about the casing of anything in the string, would just be to add the I flag after the end of the regex, which tells it that the case is insensitive. So if we search for this now, we'll get back true. Okay, and you can see that we get back this object here for the match, and that's because if I was to have another there in the string, when we add one here, for example, and I run this again, what we'll see is we still only get back the first match, right? But if I put a G flag here, which means keep searching even after the first match, and it flips it because it likes GI more than IG for some reason. So if I save this and run this again, what we'll see is we still get back there, but that's because we're only searching for the start. So if I get rid of the start here, what I'll see is I'll get back all the matches now if I get rid of that caret character at the start, right? So we're searching for every single possible there in the string, and in this case, there's two. There's the one that's the capital, and then there's the one that's the lowercase. Perfect. So one thing I kind of want to show here right before we end this is that we can kind of have a little bit of funkiness going on with these regular expressions if we're not careful. So if you think about this sentence, let me get rid of this other there for a second. I'll change this back to was just so the sentence makes more sense. We have a ... at the end. So imagine we want to ask for a string that ends with a ... Intuitively, you probably would say ... and then we would say a $sign, right? So if we run this, we get back a ... at index 30 or 43, right? So that actually works for us in this case, but probably not for the reason we think. So if I get rid of the $sign and I search for just a ... let's see the difference. Now I'm matching the. Okay. So what is going on here? I'd like you to think about this for a second. This is where things can get really, really tricky with regular expressions. Okay, so once you've had that thought, if you think about this, the dot, where was it? Right here, it matches any single character, right? So we are saying any single character, any single character, any single character. So of course, it's gonna match the first three because those are any single characters. But we don't want to match that. We want to match the literal dots at the end here, right? So if I do a backslash before these, and I'll explain what's happening here before I run this. Now we'll get back the correct answer, which we're looking for, which is index 43, which are these dots at the end. So these backslashes allow us to escape characters that we're looking for the literal character. So things like these stars, question marks, pluses, all that kind of stuff, they mean something special in regular expressions. So if we want to actually search for those items, we have to escape it and tell the regular expression, hey, I don't want you to actually look for any character here. I want you to literally look for the period of the dot, right, as an actual character itself. Okay, so just be aware of that. Escaping is definitely an important thing when it comes to using these special characters when you're actually searching for strings that contain certain types of items. Perfect. So I hope that that was valuable for you. I know that this is definitely quite a tricky topic and we only scratched the surface, but this covers quite a deep amount of stuff that we can actually do in practice using regular expressions. So if you did find this valuable, I'd love it if you could like the channel or like the video and subscribe to the channel. I'd love to hear in the comments, what do you think of regular expressions? Have you used them in other languages? Do you enjoy using them? Do you find them kind of fun? Do you find them really annoying? Do you prefer using kind of other methods? What do you kind of feel about this? What we're going to do in the next video is go through a whole bunch of examples for this, some more practical examples, for example, like searching through emails and things like that, just so we can get a bit more practice with how these actually work if we were to actually try to build an application with it. So I will see you in that exercise video. See you later.